Lorentz transformation for relativity. Hendrik Lorentz created the universal gamma factor for the transformation equations of Einstein's relativity. The universal means also to have the same one for any inertial frame. There are two frames of references. The first is still a light, which travels along the positive axis of x, is transmitted according to the equation x equals ct or x-c equals 0. The other frame is moving with speed v. A light, which travels along the positive axis of x prime, is transmitted also. Having v and c constant presumed Einstein to believe that variant time periods are in work. Thus, for the one is our time t and for another is alien time tau. Then a light signal, which travels along the positive x prime axis, takes a route x prime equals c tau. When the frame is sliding on x coordinate, then our animation shows ct equals c tau plus vt. This is the logical equation to have two frames related according to change time rate for both frames. The observer in the stationary frame had the impression that time in the moving frame runs slower than his. However, the observer in the moving frame presumes he stays and our frame moves, and from it our time runs quicker in relation to his. According to the animation, our observer presumes that time in the moving is just 2/3 of ours. On the contrary, the observer in the moving frame thinks that our time is 3/2 of his. Since the promoting theorem speaks about slower time in another frame, the conclusion is, there does not exist any universal gamma factor that would be valid for both frames equally. Einstein thought about similar considerations to light rays, which are being transmitted along negative x coordinate. The calculation for it is c tau equals ct plus vt. From our view and in accordance with the animation, we presume that time in the moving frame runs quicker, thus for 4/3 of ours. From that frame view, our time runs slower just for 3/4 of that. When the stationary observer compares both negative and positive x coordinates, he does not see the same proportional quotients there. The similar case is for the other frame. Hence, there does not exist any universal quotient, the universal gamma factor, for relativity. Since it is impossible once to have 4/3 and then to have 2/3, and then to say they express the same value, or to have once 3/4 and then 3/2 for the observer in another frame, so the looking for the universal quotient had not to run during creating the theory about relativity. Albert Einstein first proposed two formulas for relativities to have plus and minus direction on x coordinate. Thus, he had two factors for transformation formulas. Later, Lorentz came with the equation for a sphere in three-dimensional space with center x equals 0, y equals 0 and z equals 0 and diameter ct. Thus he had two spheres with coordinates x, y, z and x prime, e prime, z prime. Then he excluded direction y and z by having y equals e prime and z equals z prime. Thus he entered our animation just on a line. However, he has all in quadratic form as is matched. Mathematicians solve them by the way we were doing first at animating Einstein's proposal. However, Lorentz gives the formula that never is valid for a line, so never is valid for x coordinate. Namely, the gamma factor represents the quotient for time periods in each frame. Using math, we get from the gamma factor the equation c squared t squared equals v squared t squared plus c squared tau squared. Now it is time for you to decide what is right for x coordinate, whether c squared t squared equals v squared t squared plus c squared tau squared, or ct equals vt plus c tau. Do you think the x coordinate is a triangle as Einsteinian physics claims the quadratic equation is for x coordinate? Linear formulas are for x coordinate as everyone knows it. But Pythagoras's formulas must be for a right triangle, and therefore could not be for the Lorentz's x coordinates. The conclusion is, the transformation equations of Einstein's relativity are really the transformation of a line into a triangle in accordance with math. Want to know more? Read the chapter, Relativity versus Reality, in the book Physical Model versus Standard Model.